Hey AP Scholars, check this question out. Recursion 1, changePi. It's a little weird because it's a string builder type of question. And it's been a while since we built some strings. So we're going to take a look at this question. It's going to follow a similar pattern to our count X or count 7 question. But it's a little weirder because now we're replacing strings. So it'll feel strange. But when you look at the answer, and I think you'll see the pattern. You'll see the count 7. You'll see the count X framework inside of this question. This is kind of like this recursion as a loop type of structure. Okay, so let's take a look at the question just to make sure we know what's going on. So basically, we're given a string, and we want to return a new string, I should say, that replaces all the instances of the letter P followed by an I with a string that is 4 characters long, 3.14. So for example, if this was our string, xpix, it should be, the new string we return should be x 3.14x. So that's the story there. So what do we do? So basically, here's the plan. Here's the plan. I'm going to draw the plan out. Here's our xpi 4. I'll put that as an example, if my pen can work. Pi x, I guess. Xpix. So what we want to do is we want to look at, I'll try red. Let's see if I can get colorful. We want to look at 2 characters at a time. So I'm going to be like, hey, let's look at the first 2 characters. If that's pi, then I'm going to return 3.14 plus, feed the remaining part of the string into the function and recall that recursively. If it's not, I'll just put that piece, I'll return that piece, plus I'll feed the remaining part of the string into the function recursively. I guess I only put the first character in there. Okay, so is this pi? No. So what I want to redo is I want to return x plus like the recursive computation of pix. And then I want to do this with pi. Oh, so it is pi. So now I want to return 3.14 plus the recursive calculation of the rest of it. I want to jump forward 2 now because I've returned the pi. So I just want to have the x. And now that is too short. It can't possibly be pi. So I'll just return x. So what I'll end up getting is x plus 3.14 plus x. So that's kind of the ploy. And each one of these here and here, each one of those things is going to be just a recursive method call. And I think that'll be the story. So let's take a look at the actual answer. So here I am checking to see for my base case if the length is less than 2. If the length is less than 2, there's no pi in there, right? And we're at the end, so I'll just return whatever's left over because it's going to just turn out to be the same. Just like in this question, right? There's an x on the end, it stays there. It's fine. It's okay. If there was a pi at the end, we would have caught it already, so we don't have to worry about it. So then, if that wasn't the case, what I'll do is I'll take a look and see if the first 2 letters are pi. So I take the substring of 0, 2, that gives me the first 2 letters, and we'll compare that to pi. So if that was pi, then I will return 3.14 plus the rest of it. So I actually could just do, I don't actually have to do that. I think I can just do this here. That'll make it a little bit cleaner. Let's just confirm that works fine. Yeah, that works. So I'll just do the rest of it. So this is, the first 2 letters, and that is the remaining letters after it, right? And that only works if it's a pi, because I'll show you what happens if it's not a pi. If it's not a pi, then I just add on that first letter, and then I feed the remaining part of the string, and I'll get rid of that unnecessary bit there, to the pi. Notice that, like, if I don't find pi, I just want to add the first letter, and then I send the rest of the string to changePi recursively. So that's what's going to create this kind of cascade. That's why I only return the x this time. I put in the 3.14, and I have to jump ahead. I have to skip over the pi to get all the way to just another x. So each one of these is the recursive call of me saying, changePi, with this inside of it, and changePi so that I can process the remaining part, changePi with that inside of it, and so on. So that's where this structure comes from, and hopefully that makes sense. And if not, then we can look at this in class and talk one-on-one. I think sometimes these require a one-on-one conversation. So yeah, don't give up if it still doesn't make sense at the end of this video. Anyways, thanks for tuning in, and hopefully that helped out. And if not, then yeah, let's talk more. Okay, thanks, AP Scholars.